I'm tackling a multiple-choice question about MultiTaskElasticNetCV, a machine learning model from the Sklearn library. This model is used for multitask regression, meaning it predicts multiple things at once. It uses elastic net regularization, a mix of lasso, L1, and ridge, L2, techniques, to prevent overfitting. We're evaluating its performance using cross-validation to find the best hyperparameters. The question focuses on the MultiTaskElasticNetCV model and its hyperparameter tuning. I specifically need to understand how this model works with cross-validation to find the best settings. Think of it as trying different recipes, hyperparameters, to achieve the best results. I'm presented with 4 statements about the model's behavior. My job is to identify which statements are correct, which requires me to understand the model's parameters and hyperparameter tuning process. Statement A claims that the model automatically tunes both alpha and L1 ratio using cross-validation. I need to verify if this is true by checking the model's documentation. Alpha and L1 ratio are crucial hyperparameters controlling the model's regularization strength and the balance between L1 and L2 regularization. Statement B says we can provide a range of alpha values for the model to explore. If we don't, it uses a default range. Alpha controls the overall strength of regularization. I'll confirm this by consulting the documentation. Statement D focuses on the CV parameter, which governs the number of folds used in cross-validation. Cross-validation helps to obtain a more reliable estimate of the model's performance by splitting the data into different subsets for training and testing. I need to confirm that this parameter does indeed control the number of folds. I evaluate the MultiTaskElasticNetCV model's performance using cross-validation. This helps me find the best hyperparameters without overfitting to my training data. It's like testing a recipe on different batches of ingredients before deciding it's perfect for serving. I use cross-validation to assess the MultiTaskElasticNetCV model's ability to generalize to unseen data. I split my data into multiple folds, train the model on some folds, and test its performance on the remaining folds. This process helps me avoid overfitting and get a more reliable estimate of the model's performance. This is essential for obtaining robust results. The "CV" parameter in MultiTaskElasticNetCV lets me control the number of folds used during cross-validation. For example, if I set "CV equals 5", I'll be using 5 folds for training and testing. More folds usually lead to a more reliable estimate, but it also increases computation time. No, it's not guaranteed that the best L1 ratio will give the absolute lowest mean squared error, MSE, for each individual target variable. Instead, the model finds the L1 ratio that minimizes a combined error metric across all targets, achieving a balance between all target variable performance. Think of it like finding the best compromise when multiple people have different preferences. It may not be perfect for each individual, but it's optimal for the group. The alpha's parameter in MultiTaskElasticNetCV lets me specify a range of alpha values to explore during the search for the best hyperparameters. If I don't provide a range, the model uses a default range. Alpha controls the strength of regularization. A higher alpha means stronger regularization. MultiTaskElasticNetCV automatically tunes both alpha and L1 ratio using cross-validation. This is one of the main advantages of using this function. I don't need to manually search for the best values. That saves time and effort. This is the core machine learning model I'm using for multitask regression, predicting 2 target variables simultaneously. It uses elastic net regularization, a hybrid of lasso and ridge, to prevent overfitting. My dataset contains 3 features that I use to predict 2 target variables. This is the context for my multitask regression problem. This is the collection of data I'm using to train and test my machine learning model. It's made up of rows, samples, and columns, features and target variables. This refers to the process of optimizing the hyperparameters of the MultiTaskElasticNetCV model to achieve optimal performance. Hyperparameters are settings that control how the model learns, not learned during training itself. I'm focusing on how MultiTaskElasticNetCV automatically finds the best settings, hyperparameters, for ALPHA and using a clever method called cross-validation. It's like trying different combinations of these settings to see which combination results in the best model performance. We're working with a dataset having 3 features that describe the data points, and we are predicting 2 different target variables simultaneously, which is a hallmark of multitask regression. The quiz questions test our understanding of how MultiTaskElasticNetCV works, especially its ability to automatically fine-tune its parameters using cross-validation. This is a specific machine learning algorithm from the Sklearn library. It's designed for multitask regression problems, and it uses a clever mix of L1 and L2 regularization called ElasticNet to find a balance between model complexity and accuracy. This is a technique to ensure that the chosen hyperparameters generalize well to unseen data. I'll use the data multiple times, each time leaving out a different portion for testing. The number of times I divide the data into training and testing sets is controlled by the CV parameter. The ALPHA and parameters control the strength of regularization in the model. ALPHA controls the overall strength, while controls the balance between the 2 types of regularization, L1 and L2. The goal of hyperparameter tuning is to find the best combination of ALPHA and that minimizes errors. I'm tuning the hyperparameters, alpha and L1 ratio, using the MultiTaskElasticNetCV model. This means I'm automatically searching for the best combination of these parameters to minimize prediction error. Think of it like this: I'm trying different settings on a machine to get the best possible output. I have a dataset with 3 input features, like height, weight, and age, and 2 things I'm trying to predict, like blood pressure and heart rate. Multitask learning allows me to learn relationships between these features and targets simultaneously. I'm using a specific type of regression model called MultiTaskElasticNetCV from Sklearn. Multitask means it can handle multiple targets, and ElasticNet combines lasso and ridge regression to prevent overfitting, where the model fits training data too closely and doesn't generalize well to new data. CV stands for cross-validation, a technique to find optimal hyperparameter values. I use cross-validation to test the model's performance. I split the data into multiple folds. The CV parameter specifies how many. The model trains on some folds and tests on others, preventing bias in performance estimation. This helps me avoid the pitfall of overfitting my model, where it works really well for my existing data but poorly for new data. I need to find the best values for alpha and L1 ratio. Alpha controls the strength of regularization to prevent overfitting, and L1 ratio determines the balance between lasso and ridge regularization within the elastic net. Finding these optimal values is crucial for model performance. It can either provide a range of alpha values to try, or let the model use a default range. I'm trying different alpha values to see which one makes my model perform best. The model automatically searches for the best L1 ratio through cross-validation. I don't need to specify values here, because the model will do that for me. After the cross-validation, I select the model with the best hyperparameter combination, alpha and L1 ratio. That gives the best performance in terms of a combined error metric across all target variables. I'm selecting the most efficient machine setting. I want to use the MultiTaskElasticNetCV model to predict multiple target variables at once. This is a type of MultiTaskElasticNetCV. My data has 3 input features, things I use to make predictions, and 2 output variables, things I'm trying to predict. I need to find the best settings for the model's ALPHA and parameters. These control how much the model is regularized. Too much, and it's too simple; too little and it overfits the data. I'll use CROSSVALIDATION to find the best ALPHA in values. That is, I'll split my data into multiple subsets and train and test the model on different combinations to prevent overfitting. After cross-validation, I will pick the ALPHA and that give the best overall results. The MultiTaskElasticNetCV model automatically searches for the best ALPHA in values using CROSSVALIDATION. It does this all by itself. I don't have to do this manually. I can choose a specific range of ALPHA values to test. If I don't, the model will use its own default range. The CV parameter tells the model how many subsets to split the data into for CROSSVALIDATION. Statements A, B, and D are correct about the behavior of the MultiTaskElasticNetCV model. That's a great learning experience. I'm using the MultiTaskElasticNetCV model, which means I'm doing a type of regression that can handle multiple outputs simultaneously. The hyperparameter tuning part tells me I'm trying to find the best settings for this model. My data has 3 features, like height, weight, age, that I'm using to predict 2 different things, like blood pressure and heart rate. I'm using a specific model from the Sklearn library called MultiTaskElasticNetCV. This is a fancy name for a type of regression that combines 2 regularization methods which help prevent overfitting of model to data. These are the settings I can adjust to fine-tune my model's performance. Think of them like knobs and dials that I adjust to improve the model's accuracy. This is one of the settings for the model I'm using. It's automatically adjusted during the process of tuning hyperparameters to get the best model performance. It controls the amount of regularization that is applied and helps find the balance between accuracy and complexity. Another setting that helps prevent overfitting to data. It controls the mix between L1 and L2 regularization. The model automatically determines the best value, balancing simplicity and accuracy. It can either choose a specific range of values to test for alpha or let the model use its default range. It's like deciding whether to manually select testing values or to let the system do it automatically. This setting determines how many times I split my data to train and test the model. More folds mean more reliable results but can be more time-consuming. I'm using cross-validation, a method to avoid overfitting and get a better idea of how well my model will generalize to unseen data. I split my data into several chunks for training and testing. I train my model on the training data chunks. I evaluate my model's performance on the held-out data chunks, assessing how well the model generalizes to unseen data. I find the best combination of settings, hyperparameters, that minimize error. I pick the best set of settings that provide best model accuracy on unseen data. Ultimately, I get a model with the best settings, ready to predict new data. I'm using MultiTaskElasticNetCV, which automatically tunes 2 key parameters, ALPHA, and using cross-validation. It's like it's searching for the best combination to make the model accurate and avoid overfitting. I'm using SKLEARNSMULTITASKELASTICNETCV, a machine learning model that is perfect for handling multiple regression problems simultaneously. It combines LASSO, L1, and RIDGE, L2, regularization for improved performance. I use CROSSVALIDATION to evaluate my model's performance reliably. I split my data into multiple folds and train, test on different combinations to obtain a more robust estimate of performance. The "CV" parameter specifies how many folds I want. The ALPHA parameter controls the strength of regularization. MultiTaskElasticNetCV searches for the optimal ALPHA value within a range that I can either specify or let the algorithm select for me. A higher ALPHA means stronger regularization, which helps prevent overfitting but might lead to underfitting if too high. The parameter determines the balance between LASSO, L1, and RIDGE, L2, regularization. A value of 0 is pure RIDGE, 1 is pure LASSO, and values in between are a mix. MultiTaskElasticNetCV finds the best balance during its search for optimal hyperparameters. I use mean squared error, MSE, to assess my model's prediction accuracy. Lower MSE values are better, indicating that my model's predictions are closer to the actual target values. This is a crucial metric that is used by MultiTaskElasticNetCV during cross-validation to determine which hyperparameters are the best. After cross-validation, MultiTaskElasticNetCV selects the best combination of ALPHA and that minimizes the combined MSE across all target variables. These optimal settings are then used to train the final model.